Hello, thank you for joining me. I'm Daniel Devine, and I'm the Integrated Control Panel Specialist for Siemens. Thank you for joining me today for my demonstration of our Simaris Design tool. Here on this first screen, you'll see our web page for our control panel section, www.siemens.com/control panel. On there, you can download the tool and you can also download many other white papers and other assets regarding to control panels. Here's my contact details. Any UK customers with any control panel questions regarding standards or our tools, please feel free to get in touch. Before I do my demonstration, I've just got two slides I want to show you just to explain a little of why we do a short circuit calculation when we're determining that for our control panel. So in the 61439 IEC standard, verification of a short circuit withstand can be done by two methods, testing or comparison with a reference design, checklist or calculation. It's the second one here, the checklist or calculation, that we're going to do today. Okay, now testing can cost a lot of money, hence why we're interested in doing the calculation using the Siemens tool. As you may also be aware, short circuit verifications can be omitted in certain circumstances. For example, if you're using a circuit breaker that has a current limiting capability with a cutoff current of equal to or less than 17 kA. And we actually have tables and circuit breakers to offer you. So if that's again something you would be interested in, also get in touch. My last slide. Before we do the calculation, I just wanted to talk about this. So here we're looking at the influence of cable lengths and cross sections on the short circuit current. The tool we're going to look at today will take into consideration attenuation. So to explain what that means, for example, if we take this particular example of a transformer 2000 kVA at the point of infeed, we could be looking at 52.5 kA. But looking at our table here, if we have our, for example, our control panel or our motor is 20 meters away and we're utilizing 70 mil squared cable, the actual short circuit at this point will be 25 kA. Okay. The great thing about the tool we're going to look at today, it will ask us how far away the motor or the panel is. And if we know that information, then great, because the tool will take this attenuation into consideration. So without further ado, let's have a quick look at the tool. Okay, once it's downloaded, Simaris Design can be used in the offline and online setup. Okay, and this is the screen you'll see when we first open it. So as you can see here, we can open an existing project if we've got one already. We can open a demo project to have a look. It's kind of like a tutorial. We're going to create a new project. Okay, so I'm going to click on next, and we can give that project a name. Say, for example, okay, and you can add more details if you want. Here is where we input the data for the medium voltage. Okay, so obviously you can see we've got nominal voltage 25 kV for this example, but we can change that if required. Okay, and the same with the maximum short circuit power and the minimum short circuit power. You can also change the cross-sectional area, minimum and maximum of the cables for the medium voltage. So once we're happy with this, we'll click on next. Here now, we can determine our low voltage criteria. For this example, we're going to go with 400 volt. And we're going to leave it at 50 hertz. Finish. Okay, so now we're ready. For our demonstration today, I'm going to do a basic setup. with a few motors, a few drives. We'll maybe add one or two stationary loads also, and we'll see what output the tool gives us. Okay. Now I will show you across here. If we look across the top, we've actually got help. Okay. So there is a tutorial. There is a technical manual that will explain how you do different functionality. So you can get as deep into this as you want to. And as I say, these are okay and easy to download. What I'm going to do is a basic setup. Okay. Now, as you can see with all of the symbols here, if you hover over a symbol, it'll tell you what that symbol corresponds to. So here, for example, we've got a transformer. Here we've got a generator. For this setup, we're going to add a transformer. So left click on it, come over here, click into the area. Okay, as I mentioned earlier, attenuation, it's asking us how far away is this panel from the transformer. If we know that information, great. Okay, for this example, I'm going to set it at 5 meters. And again, here we can add what type of switching device we're going to use and the type of connection. Okay, for example, cable, busbar, and we can drop down. We can also change the system configuration and the type of switching device. Here, we'll leave it for this just to show you this example. This device here essentially is going to be protecting our panel. So this is going to be our main switching device after the cable. Okay. Finish. And here we go. It's placed it into the area here for our drawing. Okay, so if we bring our mouse back over here, as you can see, we can add sub-distribution boards. For this example, we're not going to do that. We're going to do it as if this is our main control panel. Okay, so again, hovering over these final circuit devices, we've got a stationary load. Here we've got a power outlet, a motor. This will be a fixed speed motor. Here we've got a frequency converter, a drive, charging unit, capacitive load, i.e. a power factor correction device, for example, a dummy load, and a surge protection device. Okay, so for this example, let's add some motors. Okay, so again, left click, come over here, left click again, drag, and drop. Okay, brilliant. So again, for attenuation, do we know how far this motor away is from the panel? For this example, it's 5 meters. What's the kilowatt rating? Okay, you've got the drop down menu here. And we go from 0.25 kilowatt all the way up to 250 kilowatt. Well, this is a 7.5 kilowatt motor, and there are 3 of them. Okay, you can see now the quantity's changed to 3 if they're the same size. Next, okay, so now what's the type of construction? Do we want fuseless or fused? Go with fuseless for this example. What's the starting mode? Is it a direct online, reversing duty, star delta, soft starter? Okay, we'll mix it up. We'll try a star delta next. So this one's direct online. Finish. Okay, we can see that now has been added. Again, we're going to left click, drag, drop, 5 meters. We've got a 15 kilowatt motor, one of. Again, fuseless. This one's star delta. Okay, and another 5 meters away. Again, 15 kilowatt, but this one is a soft starter. Finish. We're now going to add a drive. Left click, and again come over here. Left click again, hold, and drop. Okay, now we're prompted. Okay, so we've got the application or the type. Okay, you can see here these are Siemens drives, if you're aware, if you know of them, G120s. So you can choose for them here, or if you're unsure, you can go to application, and we can say, well, hey, what is our application? It's a pump in, and it's a basic centrifugal pump. So we'll select that. Again, what's the kilowatt rating? We can go from 0.55 all the way up to 560. Well, this one's 75 kilowatt. Next. Again, we're prompted. Distance. 5 meters again. Finish. So now you can see, and we can continue to load. So for example, dummy or a stationary load, left click and drop. How far away? Again, 5 meters. And we can change the type of switching device again and the type of connection. Okay. Well, how many poles? Is it single phase and neutral, three phase and neutral? Well, we're going to say this is a single phase and neutral load. And it's only 40 amp. Finish. Okay, I'm happy now. I've added all my loads. So again, going across the top here, if we hover above these numbers, or these items, it'll tell us each of what they are. Okay, I'm going to go for the selection, so then I'm going to move my drawing. Okay, so I'm going to move that over here. I'm going to make it a little bit bigger. Okay, so some of the functionality, I'll just quickly look at it. So for example, here we've got, so for example, we've got a motor load here on DOL. We can select that load. Okay, and on the left hand side now over here, it's telling us the type of selection here based on the standard. Now in terms of the dimensioning, so for example, do you want backup protection or selectivity? What is that? Click on the information if you're unsure, and here it'll explain all that to you. Okay, so also we've got here, if you hover over here, selectivity. Once we have a circuit breaker selected up here when we've dimensioned, we can actually look at the curves data and look at the selectivity between these two devices. Okay, so I'm going to go ahead now and I'm going to dimension these circuits. So I'm going to click on this button here, dimension all circuits. It's just giving me a warning saying it's not possible to undo dimensioning. Okay, I'll close this switch over. And hey, it's done it. Okay, so now you can see here we've got a circuit breaker selected for us, 400 amp circuit breaker based on the loads here. We've also got our motor protection circuit breakers, our contactors. Again, for the star delta setup, we've got our circuit breakers and our contactors and our overload. And we've got our soft start selected with the protective device. And again, we've got our drive selected with our protective device. In this instance, it's selected a G120. Okay. Here we've got our miniature circuit breaker protecting the single phase and neutral load. So I'm happy with all of these devices, but what other information? Again, this tool, the reason we were doing this was for our short circuit calculation. If we hover here, single line diagram with short circuit load, and click on this button. Now we can see the IK max and IK min of each of these loads. IK max, IK min, IK max, IK min, and we can see our overall IK max short circuit here, 7 kA roughly. So in just a few clicks, I can get all my devices, and what I can also get is my cable sizes and my short circuit calculations done for me. And as I said earlier, if we click on here, we can actually see the selectivity of the devices also. If we need to amend the current, for example, it's possible to do that in here. And we can see that selectivity has been chosen between the devices, between the envelope of the upstream device and the secondary device. We've had a circuit breaker chosen for us here. We can actually double click onto that or any of the devices. So here you can see we've got a 400 amp LSI 55 kA device. What we can do, this is a 3-pole, we can say, hey, I want a 4-pole device and I want an LSI G. Simply click here, catalog. What we can do, number of poles, change that to 4. Down here, we can change that to LSIG. It's given us 2 options. Okay. Now that device has been changed. And we can do that for some of the other devices if we need to. So I'm happy with this now. Okay, so what can we produce? Up here, let's click on Project Output. And as I say, there is a lot more functionality. For that, we can download from the help section in the tutorial with a technical manual, and it can explain all the other functionality that I've not shown you today. For this example, what do I want? Hey, I'll have the device list. I'd also like the cable list for my cable dimensions. And I'd like the network diagram here for my customer. Start output. Disclaimer. And as quick as that, here we go. Okay. I'll just let each page load. Okay. So as you can see, I've got my PDF of my line diagram with all of the information. We've got the project name, etc. at the bottom corner. If I just drop that down. Here, we've got all our cables, cable dimensions. And last but not least, we've got our parts list. Siemens part numbers, description, and quantity. Perfect. So I hope that short demonstration gave you a flavor of the tool. As I say, you can download the help and tutorials. As I say, I'm the integrated control specialist for Siemens in the UK, and I'm more than happy to help you with any control panel projects or anything as such. Now, the last thing for me to do is to show you quickly where you can download this great tool from for free. Okay, here is the Simaris web page where you can download this from. I'll be putting the address at the top of the page. So simply, and there are other tools here, simply click here, Simaris Suite free of charge download. And as you can see, here are some of the tools and the descriptions of what it is you'll be downloading. Simaris Design is what we looked at today. See some of my other videos, for example, Simaris Therm, and quite possibly we'll be looking at our control panel design tool. So yeah, an easy enough place to download from. Another, but the favorite of mine, where you can download this also from and where you can download some other great information, is the Siemens control panel webpage. Okay, and here we are. I'll put the web address across the top. So this is the control panel web page. Okay, you'll find lots of information here, and there are different ways of finding that information. So for example, we can hover over this and we can go to the info center. Okay, or we can scroll down and we can have a look at some other articles. This one I will be doing a video for the control panel design tool. Look out for that. And we can scroll down here. As you can see, we've got other control panel topics: UL, IEC, arc flash. We can scroll down, and here we have another link to the info center. Let's go to there. Click on the info center. Okay, great. Now that we're here, let's scroll down, and again, we've got the topics that we noticed earlier. Further down here, we've got on-demand webinars. Simply click here. What we're interested in today is here, tools and electrical engineering. Click here. So as well as all of this other information that is free to download, we've also got the Simaris Design tool that we looked at today, as well as other tools. So thank you for joining me. I hope you'll watch some of my other videos on some of the other control panel tools we've got. So good luck with your control panel design. And as I say, if you need to get in touch, please do.